Now, yesterday what we did was we did a quick primer on AI for product managers. Of course, we deep dived into a lot of the concepts required. And today we are going to do the same for tech for product managers, right? Now, this is something that a lot of people worry about, a lot of people get confused about. But today we are going to try and demystify it in the next 1 hour or so, right? We're trying to understand what is it that really is required for a PM, what can you do to speak in the engineer's language, and how you can understand the basic building blocks of the product that you're going to be shipping as a product manager, right? Now, as of now, every startup, every bigger company, every medium-sized company, they all try and prefer if their PMs are technically fluent, right? What I mean by technically fluent is not that they would want their PMs to code, or not that they want their PMs to be extremely great tech wizards, but they want them to be technically fluent, which means that if there is a situation where that PM is with an engineer, that PM should be able to hold their own. It should not be that that product manager is just caught in the lights. So that is what the major focus is, and that's what we're going to try and cover in the next 1 hour or so and try and understand. Right. Now, the first thing that we'll try and understand is why do you even need this, right? And this answers a lot of the questions that people have when they try and think about, okay, what kind of product management, what kind of tech do I need to know as a product manager, right? What is it that I need to know, or what is it that is expected out of me? Because there is so much content on it, there is so much said about it. Since a lot of you haven't naturally been engineers, there may be a slight hesitation in terms of, okay, I don't really know this. So the first thing is to understand why is this important. Now, the first reason is, of course, you need to understand how your product works, right? Not at the code level, but at least at an architecture level, right? I'll give you a very simple example, right? Let's assume that you are a product manager at MakeMyTrip, right? Which is a travel company that so many of you use. Now, if your user searches Pune to Delhi on the 13th of May or 15th of May, whatever, what is happening behind the scenes, right? MakeMyTrip, of course, doesn't operate their own flights, right? Indigo does, or Air India does, or Akasa does, and so on, right? So why, or what happens in the background where how is MakeMyTrip able to show you flights from all these airlines in one page with their prices, with the potential discounts, with all the offers, with seat selection and all of that, right? The answer, of course, is APIs, which is application programming interfaces. MakeMyTrip is basically calling Indigo's API or SpiceJet's API or Air India's API, collecting all the results and presenting it in front of you. Now, on paper, this may sound complicated, but in essence, this is not that complicated. In essence, this is actually fairly straightforward and fairly easy to understand if you understand the inner workings of it, right? And if you are a PM at MakeMyTrip, but you don't understand how this works, right? You literally cannot do your job, because the core page, right? The main page that lists because of whatever gets done on MakeMyTrip, that gets done because of this tech. Now, on the paper, it sounds complicated tech, right? You are trying to integrate several things from there, but at the end, it's just data transfer. And by the end of today's session, my attempt is to make you a lot more confident and a lot more fluent with these concepts, right? The second reason is, of course, empathizing with engineers, right? Now, you need to work with engineers every single day, right? And they are, the people who will actually convert whatever ideas you have into proper PM ideas. So that is what you need to know, or that is what you need to learn, right? And I have actually had sessions with hundreds and hundreds of developers, right? And if you talk about what is the main complaint that they have with product managers, usually the answers come in the range of the PMs not understanding what the engineer wants, or not understanding what the engineer means, right? What happens because of that is you lose trust from the engineers. The engineers stop trusting you on a day-to-day basis, and that's, of course, something that you have to reduce. The third reason, and this is kind of the irony of being a PM as well, which an engineer always looks as a non-tech person, right? Your sales team looks at you as a tech person. So basically, your salesperson or sales executive is going to look at you with aspirations of fixing tech issues. Your tech person is going to look at you as aspiration of talking to salespeople and buying more time. So you're always a translator in the middle. And because of an engineer coming to you and saying that, hey, we cannot do this because of high latency. We cannot do this because of high this thing. That is when you have to understand that, okay, I need to be able to speak what my engineer is saying to be able to do this, right? So that is why it's very important for us to be good at tech, or to be understanding of what core tech means. And this is basically the skill that we are trying to build up. Now, let's try and understand how any product works, or any technical product works, right? Very simple. Any product works on a 3-tier architecture. There is the presentation layer, there is the application layer, and then there is the database layer, right? And this is very simple, right? Very, very simple. Any product in the world, right? LinkedIn, Swiggy, ChatGPT, PhonePe, Google, any product, you will be able to break it down into these 3 layers. The first layer is the presentation layer, right? This is the layer that you can see, you can interact with, you can touch, click, so on and so forth, right? The button, the color, and so on and so forth. This is usually sometimes called the front end, also called as the UI layer at times. The second layer is the application layer. Now, this is where the brain lives, right? All the business logic, the rules that decide, what happens, and so on and so forth. So when you click on, let's say, a sign up button on LinkedIn or any other website, the application layer comes in and tests, hey, whether this email is already registered. Should I go ahead and give him sign up? Should I send him forgot password, and so on and so forth. This is also called as the backend or the server. We'll talk about why it's called a server. And the third layer is the database layer. Now, this is the memory which stores everything, right? So your user profile data, post, messages, transaction, order, whatever it is, all of that data is stored in the database layer. So what essentially happens is all these 3 layers play with each other or interact with each other to create a great visual for yourself, right? So that is what happens. All of these layers play with each other to give you a great visual. Let me show you an example of this, right? I hope you are able to see. I'll just open airbnb.com, Airbnb's website, to see this, right? Now, this is an Airbnb website. Now, remember, we are looking for 3 layers here. Everything that you see on Airbnb here is the presentation layer, right? Any website you visit, the fact that there is homes here, the fact that there is experiences, services, there is a where, there is a when, there is a who, all of this is the view or the front end that is there. The first layer that you see here, the presentation layer. So a front end developer would have coded this either in CSS, HTML, all of those kind of stuff, which is basically protocols or code languages which allow you to create great visually looking websites, right? So this, all of it is visual layer. But now imagine what happens when I click on this, right? There is options that are coming nearby, North Goa, Candolim, South Goa. But for someone, let's say, sitting in US, the options would probably not be this. The options probably will be California, Miami, Orlando, etc. Now, how does Airbnb's front end, which is this visual layer, know that popular homes in North Goa is probably the best thing to show me, who is someone who's sitting in Bangalore, right? This is where the second layer comes in, which is the application layer. So what is happening here is that when the front end gets coded, right? When the front end gets built, what happens is the front end engineer creates spaces, creates empty spaces for the images, for the text, for all of that to come. Whenever the application is loaded or whenever the website is loaded, the front end requests the backend to serve data to it, based on which it actually renders whatever you see on the screen. So what has happened here? When you have loaded, I'll just type airbnb.com and here it is, right? So now what is happening here is that whenever I've typed airbnb.com, the front end of Airbnb, all of the things that you see here, they went and there is a trigger request to the backend where the backend is asked, what should I show them, right? This structure of there should be an image here, a heading here, there should be the price written here. All of this is done by the front end engineer, but they create hollow spaces for that. The data that comes in, right? What image to show here? Should I show guest favorite or not? What should be done here? All of that is requested from the backend, and then backend gives you that data. If you see clearly, I'll just paste Airbnb's web URL in a Google Doc so that you understand, right? Now, this is the web URL that Airbnb has posted. I just typed airbnb.com. It's actually the web URL that is there. I just make it a little bigger for you to see, right? Now, you understand how this data is going on or how this transfer is going on. So what is going on here is, even though I typed airbnb.com, you see after airbnb.co.in, there is a lot of gibberish. There is a lot of stuff that is being passed on to the backend via this website so that all of this gets rendered properly, right? So this basically what happens is, if you see the locale is EN, which is English, then this is setting on new domain, and then there are some codes. Of course, we don't know what these codes mean, but basically this is how whatever is getting loaded, right? Now, to store this information, right, for the backend layer, for the server to actually fetch this information, it cannot have it ready all the time, right? Because it will have to store it somewhere, because on Airbnb, there are thousands and thousands of properties listed. So it will have to bring it from somewhere, right? That somewhere is the backend or the database. I have a small artifact to show you how this works. Now, I hope you are able to see this. Now, what this does is I have created like 4 things that are there, right? Let's say this is a user action is sign up, then liking a post, searching a product, and sending a message. And I'm trying to showcase how the 3 architectural layers play alongside each other. Let's take sign up for the example. So I'll click on sign up. So what happens in the presentation layer is, first, the user is going to fill a form, right? Then the application layer, which is the backend, is going to, I'll just zoom this in up for you guys to see. Yeah. So what happens is, first the user will fill the form, right? When they are signing up, they will put their email details, etc. This is done by the presentation layer. Why? Because this is done, if I say on Airbnb, if I just maybe log out and try to sign up. Yeah, I'll just try to sign up. There is a form that comes in, right? There is a form that allows me to enter my stuff here, right? That's the same thing. This is by the presentation layer. Now, what happens there is, there are few checks that are required. So the application layer validates whether the email is valid or not, right? Is the password strong enough and stuff like that. I'm sure you would have seen that on different websites. So that validation is not coming on the front end. The presentation layer is not doing that validation. It's being done by the application layer. Then the application layer checks from the database layer that, okay, is this user already there, right? So it would basically do a query which will allow it to figure out whether this user already exists or not. The result will be processed, and then the final result will be shown, right? The result, of course, will finally be shown on the presentation layer. Let's take another example. Let's take the example of another action, which is liking a post, right? So now what are this? The first thing is that the user clicks like. Now this happens on the app or the website, which means that this is the presentation layer. When this happens, the next step happens, which is the application layer receives the reaction, which means that the application layer receives the like, the share, the whatever button is there. And it basically then checks if there is an already existing reaction on this post, right? If you have already reacted, then it would basically toggle it off. Sometimes the front end layer will not do anything. Sometimes it will remove the like. So there are multiple ways in which the presentation layer will act on it. But the first thing that the application layer will go and check from the database is whether there is an existing reaction or not. If there is an existing reaction, then it will toggle the reaction and remove it. Basically, if I see here, it will go here. If I click on it, okay, maybe just I should log in and right. So if I just like it here, it will of course ask me to create the wish list. Once I create the wish list, it's going to the backend layer is going to process it, and then the database layer is where it gets saved. Now the application layer will toggle the reaction. So if it was a like, it will remove the like and reduce the total like count by 1. And then that record is going to get updated in the database. And then finally, it's going to be sent to the presentation layer where the interface for the user is going to be changed. Now, every single product, right, is an interaction of this, right? If you see what happens is the like happens, this basically gets a reaction received. Now, based on this, 2 things get triggered, right? One is the application layer receives this data and the database layer starts checking if there is an existing reaction. Based on that, the reaction gets toggled. The database layer updates itself in the number of count that is required, and then it's finally presented in front of it. So this is basically how common use cases or common features that are there get done. Similarly, if you look at search, the user would type query, it would be processed by the application layer, the database layer will match it, the application layer will give back results, and the presentation layer will present it. So every single product that you see, right, is an interplay of these three layers playing against each other, is an interface playing against each other, where the presentation layer does the job of communicating things to the user. So on Airbnb, the presentation layer is this screen, and it does the job of communicating things to the user every day. The architecture layer, or the application layer rather, is basically the layer where things are processed, where things are bridged between the database layer and the presentation layer, and the database layer is where things are getting stored, right? So that is basically how you need to look at every single product that is there, right? Now the presentation layer is usually written in codes or in web pages, like in web protocols like HTML, CSS, JavaScript, etc. HTML is basically to define the structure and content, so heading, subheading, underline, all the basics that you learned way early in your class. CSS is of course about design, color, font, spacing, layout, all of those kind of things. And JavaScript is of course adding interactivity, animations, dynamic behavior, change of state, stuff like that, right? Great frameworks are built on React, Angular, Vue.js. You don't need to know all of that. Basically, but all you need to know is everything that you see on the screen right now. They are all your presentation layer or your UI layer. Now, an engineer decides based on your requirement. Let's assume that you gave an engineer a standard web page which has no interactivity, nothing to change and stuff like that. What will the engineer do? They will say that, okay, I'll just make a simple HTML page and put it out. Let's assume that you gave them with a lot of custom fonts, some great design, some nice spacing and all of that. They will write the CSS for it. If you give some interactive element saying that there should be an animation, there should be a shimmer effect on the button and so on and so forth, they will select JavaScript. So basically, based on the complexity of what you have given, the engineer decides which or how to basically do this. CSS is what most people write in web pages because it covers most of the use cases and it's very publicly available as well, and so on, right? But of course, whenever you have to add interactivity, you will need to do that. Now, you don't need to worry about this. It's mostly an engineer's job, but you do need to understand this. Now, the second thing that you have to understand is the business layer. This is the application layer, right? What happens in the application layer? There are four kinds of things that can happen. So whenever a user clicks something or a user sees a result or stuff like that, there are four things. What are these things? First, the application layer will receive the request. So if you click sign up on Airbnb or LinkedIn, that click will actually trigger an application layer request packaged with the email, password, or whatever Google token or whatever is being used alongside it, right? That gets packaged and that gets sent to the server. Server is our application layer. The second thing, it processes the logic. So for sign up, for example, the logic is very simple, that the email should not already exist. If the email already exists, then it's not a sign up. You need to redirect the person to sign in. Now the front end layer does not have all this intelligence. They don't know what email is there because Airbnb would have millions and millions of users. You cannot store all of their data on the front end because it's risky. Second, it won't work properly. So that is why the application layer is there. Whereas the second thing is to process the logic. Third thing is to query the database, right? What I mean by querying the database is if you have to figure out whether a particular entry on the database exists or not, whether you have to figure out where that exists and so on and so forth, you will have to query it. For example, if you are signing up, then whether that email exists or not is where you'll have to query it. Fourth is that you create the response. So based on what the database said, the server decides if the email is new, create an account, and so on and so forth. That is basically where the last part of the application layer is there, right? So this response, whatever is generated by the application layer, then gets rendered in HTML, CSS, JavaScript, whatever, and gets sent back to the front end layer or the presentation layer for the people to see. right? Now, where does this run, right? Where the front end, we understood that this runs on your Chrome, this runs on your computer website. But where does this part of the code run, right? So this part of a code runs on something called as a server. Now, what is a server? Server is just a computer, but instead of your computer sitting on your desk, it is sitting in a data center somewhere else, right? So for example, LinkedIn servers are in Virginia in US. Flipkart servers probably would be in Mumbai, right? Google has servers all over the world. So all this application layer, right, this backend sits on a server, which is basically just a computer where all of this computation can be done, right? So a software that actually makes the computer act like a server is called a server software. So those softwares are basically Apache, Nginx, most common ones. And of course, usually these servers are running on operating systems like Linux, Ubuntu, CentOS, etc. Right? To give you an example, let's take the example of Razorpay or PayPal or Stripe. Now what happens is the front end is going to collect your card details, your payment details, your UPI details and everything. But the backend or the application layer is what is going to process all the payment logic, right? That is how in Swiggy, for example, the application layer is going to process the order routing, because the front end is going to show which delivery partner has got the order, but the application layer is what is going to get that order, or what is going to process that order, or what is going to build that order for the delivery partner who's going to get it. So that is about the application layer, and this application layer, like I said, runs on a server. Server is just a computer that is stored somewhere across the world, because how many physical computers would you have? And second thing is, you don't want all your server code to be on one computer, because then it's risky, and if that computer breaks down and so on and so forth, which is why companies offer cloud computation, which is basically the computer is not really a physical device, it's just on the cloud, or is just somewhere in a data center in Mumbai or a data center in US or wherever. And that is where the application layer works, right? Now, the last is database, which is the final layer. And that is where, of course, database is all about storing, right? Where all the data about your users get stored. So for Airbnb, each and every property; for Swiggy, each and every delivery rider's profile; for Zomato, each and every restaurant's profile. All of this would be stored in a database, right? Now, there are two main types of database that you as a PM need to know: SQL databases and NoSQL databases. Now, SQL databases are basically MySQL, Postgres, and so on and so forth. Think of these as Google Sheets, right? So data is stored in rows and columns in like structured tables like a Google Sheet. You have, let's say, a users table with a column name, email, password, and all their details. You have an orders sheet with order ID, name, email, password, and so on and so forth, and stuff like that. All of that is there. And these tables can reference each other, right? Just like you do a VLOOKUP in Google Sheets, where you can look up some other part of the sheet and see and match it with here. The same thing can happen with an SQL database. So, which means that logically, SQL databases are great when your data is very clear, when there is a very consistent structure and so on. So things like your product catalog, right? Let's say Flipkart's catalog, or Zerodha's trade records, right? All the records of each and every trade made on Zerodha, IRCTC's booking data. All of these are very structured data, and all of these are very SQL friendly. The second is NoSQL databases. Now, this is your MongoDB, Cassandra, etc. If you've heard those words, think of these as a folder full of Word documents. So in your computer, I'm sure you might have a lot of folders where you just dump every single document, right? Each document can be very different, right? One document could be a brochure for a B2B client. Another document could be your PRD, another document could be a data analysis report. So all of that is completely different, right? And some could be, let's say, an image, some could be a PDF, some could be a Word file, and so on. So that is what NoSQL is, which is where the data is very messy and changes very frequently. NoSQL is important. Now, what is the most common? Social media post. One post is going to be text, another is going to be a reel, another is going to be an image, one could be a video, one could be a poll, so many things, right? So that is where you use NoSQL databases. You don't need to worry too much about writing queries in SQL, NoSQL. AI can do a good job at it. You're not expected to do this, but you need to know this, right? You need to understand why your engineer decided to use a NoSQL database. Why did they decide to say that, no, let's put this on MongoDB versus an SQL database? The moment you know this, it becomes easier, right? To give you an example, let's say Razorpay, right? Now Razorpay might use Postgres or something like that to structure and store data, right? But let's say they have a merchant onboarding form where you can actually have merchants coming and signing up. Now that they might use a MongoDB or a NoSQL database to store, because that onboarding form is going to be very varied and flexible and so on and so forth. So that is basically what you need to know, and that is how a NoSQL database really works. Right? So you have to understand this. Now, of course, I have just shown you the architecture. I will just drop the link of this Claude artifact as well on chat so that you can see this in action yourself. This is just basically to explain how the tech works. And of course, there is one slide as well, which basically changes or talks to you about how this site works. Now comes the big part and one of the most important parts of technical concepts. So far, we've understood how these products work. There is 3 layers. There is a presentation layer, which is the UI and everything. There is the backend, which is the application layer, which sits on a server, which has all the logic and all the business stuff. And then there is a database that stores all the critical information for the application layer to keep querying and keep picking out. Now, there is one big part of this entire ecosystem that we're going to connect, which basically enables the transition between these 3 layers and between external systems as well, right? That is called APIs, and this is probably the most important concept from today's session. API essentially stands for Application Programming Interface, right? But forget the full form, that's fine, that's not a problem. You need to understand it with an analogy, and there is a very famous analogy that explains what API does, and that's what I'm going to use. Let's assume that you go to a restaurant. You are a customer, the chef is in the kitchen. You cannot walk into the kitchen and start cooking, right? You can sit on a table. The chef also will not come to your table to serve or ask, hey, what can I get you? There is always a middleman, right? What is that middleman in a restaurant? The waiter. So you tell the waiter, hey, I want this. The waiter goes to the kitchen, tells the chef either manually or through a server or through a program or through a software, etc. The chef, based on that, prepares the food, right? And then based on that, the waiter brings it back to you, right? Now, in this analogy, you are the person who comes in, right? You are the client. The chef is the server, which is the backend layer. The waiter is the API. So whenever front-end architecture, right? Whenever the presentation layer needs to interact with the application layer, they do it via APIs. Now let's take another example, right? We did take an example of MakeMyTrip, right? Now, whenever MakeMyTrip requires data, that is what are the flights that are going from Delhi to Bombay or Mumbai, today, right? Based on your requirement, what it does is it hits an API, and it's called hitting the API. Basically, it goes to the API, asks the API from Indigo saying that please tell me all the flights that you have for today from Delhi to Mumbai or stuff like that, right? Then they do the same for Air India, then they do the same for SpiceJet, then they do the same for Akasa, and then collate all of that into a beautiful presentation layer that is visualized on your screen, right? Whatever you see, whatever you show on MakeMyTrip's website, whenever that happens. Right? So very important for you to understand that is how an API works. Similarly, PhonePe, right? Now PhonePe does not, or UPI rather. Now UPI does not have your bank's money, right? UPI does not have the ability to deduct any money on your behalf. But whenever you type your UPI code and press OK, the money gets debited from your bank account. Why? The bank actually has exposed an API through the UPI system that basically says that, hey, I have authorized this front end, which is PhonePe, Google Pay, whatever, to debit money on my behalf, right? Which is basically without APIs, right? What happens is every system would have to be rewritten on their own. What I mean by that is, let's assume we did not have Google Maps API. What would happen because of that? Google Maps API being there ensures that Swiggy can actually show you a map on their product to show where the delivery partner is. Otherwise, Swiggy would have had to make the entire ecosystem of maps, live tracking, partner tracking, and all of that. Similarly, if banks did not have their API, UPI wouldn't be possible. Why? Because your data is, or your money is an Axis Bank. PhonePe, let's say, has partnered with Yes Bank. Now, how does PhonePe basically relate, or how does PhonePe basically deduct money from your Axis Bank account without APIs? Right? So that is why you need to understand that without APIs, it's going to be always there. Without APIs, you have to understand. And now let's try and understand how this interaction works, right? That is how, basically everything works, because it's not just the client, right? It's not just the front end. There are multiple places where an API can come in. And as a PM, you are likely to work with APIs constantly, right? You're likely to work and integrate APIs constantly and try to understand this. Let's try and understand from a visual in the next slide. Now, any product that you have, right? We already talked about it. Any product that you have has these three layers, right? Front end, back end, database. We already talked about it. Now we have to understand how APIs come in and play there, right? This is where the full picture of the tech stack comes in, right? We've already talked about front end, your HTML, CSS, JavaScript, frameworks, etc. We've already talked about back end, your programming languages like Python, Node.js, PHP, etc. Database, MySQL, Postgres, MongoDB, so on and so forth. The final part of this, right, is something called as tooling. Now, what is tooling? Tooling is basically the way by which developers, right, ensure that they don't overwrite each other's code, or they are able to run APIs, or they are able to deploy the code on production. Right? I'll explain that in a bit, but let me first explain APIs in a bit more detail in terms of how it flows. So for that, we're just going to go and we're going to search Postman Public API Network, right? We're just going to open Postman API Network's website, and we are going to see all the public, we're going to go to browse APIs here, and we're going to see all the public APIs that are available for developers or for product managers or whoever to build from. We're going to open one API which sounds interesting. Let's see which one we can open. Okay, we'll open something from Sport Radar Soccer, right? This is probably going to get us some details about matches going on and so on and so forth. Okay, there is a lot here. So we can open maybe any one of them. Maybe we can open Sports Radar Cricket, right? And we can open daily live schedule, right? Now, what happens in an API? What happens in an API is the API has something called as a simple API endpoint. What is that endpoint? Endpoint is written here, right? api.sportradar.com/cricket-t2 en schedule live schedule.json, right? So this is basically the code snippet that an engineer is going to enter, or that an engineer is going to add as a code. Now, what happens in an API? In an APIs, you actually have something called as parameters. So every API that you see is going to have certain parameters. I'm just going to open, the documentation for this. Yeah, there is a trial access for this page so that I can see this. Yeah, this is the one, right? So basically for this API, right, for the Sport Radar company that we are seeing here, what is happening is they have got a lot of APIs. Now to make a request, right, you have to go to endpoints, as you can see here, as they're showing. What happens is you go to an endpoint, which is basically a website, and then that website has something called as parameters. Now, what are those parameters? Those parameters are basically what data do you want from this website. So for example, for a cricket API, the parameter, if you're trying to figure out the score of a match, the parameter could be who is playing. The parameter could be, are you looking for the first innings or second innings? The parameter could be the date when the match is going on, so on and so forth. right? So this is basically there, and based on those parameters, the API gives you an API response. What is this API response? API response is basically where you or the whatever company's APIs you are using, they give you a structured response of your query. So here, as you can see, this was for Major League Baseball. This is a sample API response. So it gives you the fact that the match is closed, the full coverage was there, this was game number 1, it was a day-night game, the home team was this, the away team, what was the attendance, what was the score, where it happened in Philadelphia and all that. So whenever now, for anyone to build anything on top of, whatever is already there, right? For example, anyone to build a sport app, anyone to build data on a sport app, they don't need to worry about having to build that sport infrastructure on their own. All they can do is they can figure out sport RAS APIs, create a right structure, and then hit that, right? So that is basically how the interaction between the front end, the back end, and usually that works, right? So essentially the interaction can be via APIs, and of course the backend might sometimes not need APIs. For example, let's say you're opening the profile screen of MakeMyTrip, right? Now at this point, you don't require an external API, or you don't require an external API to give you this data. Instead, you can query the database and get that data. So this is basically a technical discussion in terms of how your engineers decide to implement it. But you can either call an API is going to give you the response, or you can just very simply go ahead and just query your database, process it, and send it back. Right? So that is how basically you go ahead, and that is how this works, right? So now finally, the backend has actually those two choices, right? The backend can actually go ahead and go forward and query a database, or the backend can actually hit an API, right? And when I say hitting an API, all I mean is hitting an endpoint where basically that URL can be hit with the right parameters, and once that URL is hit with the right parameters, it's going to give you the proper response. Now, one more part of this piece that you have to understand is the tooling. Now, why is this important? So, of course, front-end, back-end database is going to be enough for any developer to build your product completely. But another part that's extremely important is the tools. Now, there are a few tools that are very popular that you need to know. The first is called Git, which is basically for version control, right? The second is called Postman, which is for testing APIs. There is something called as Jenkins, which is going to be basically automated deployment. Then IDEs like VS Code, Cursor, etc., which are going to help you write code, and so on and so forth. Right? So one important thing that you have to do, and this is from an interview perspective as well, is you can actually ensure that you go through this stack for companies as well. So let me just open that as well. So I'm just going to open something called as stackshare.io. Very, very great website here. What you could do is you could look up any company's tech stack on this website, right? So here I'm just going to search Uber, right? And I'm going to go to Uber Technologies. And now you can actually look at the tech stack that Uber is using, right? Very fascinating to understand it. As you can see, there is a lot of stuff here. There is AI, there are some AI tools in that tech stack. Most of it is the application and data. There is a bit of utilities, DevOps, and business. Let's try and deep dive into this a little bit. For AI, if you see what tools Uber is using for AI, they're using something called as TensorFlow. And then they're using something called as Ludwig. So Ludwig is basically built on top of, you don't need to know all of this in that detail, but essentially what you can understand here is you can go through websites and go through their tech stacks to understand how they get structured, right? If you look at application data, of course I would need to open all of these, but their application layer, has got MySQL being used, there is Java, there is Python, there's so much things that are being used at application layer for different use cases. Utilities, of course, they have PayPal for payments, they would have Google Analytics working, and so on and so forth as you can open, right? So you can open any website, right? You can open LinkedIn, right? Okay, maybe LinkedIn is not here, or maybe I can just go back to this and see this. Yeah, so you can open any basic website that is there, any basic product that is there. Maybe we can open Notion. Yeah. So yeah, this is Notion, sorry. Right? So you can go ahead and understand what is going on in Notion, what is the tech stack being used. You can have, of course, discussions and all of that, but StackShare is a great product for you to understand tech stacks of different companies, understand what they're using for their servers, what they're using for their background, and so on and so forth. So I'm just going to drop the link of this on chat as well, right? So that you can look at this. This is just basically stackshare.io. Right? Again, you don't need to worry about going into the depths of it. It's fine if you just know it overall. But yes, overall knowing it is very, very important. So finally, to summarize, 3 layers: presentation, application, database. Presentation, all about the UI layout and what is visible. Application layer, the business logics. Database, wherever data is stored. Now, the interaction between all of these can happen via APIs. Sometimes it doesn't need an API. Sometimes it's a query. The application layer can just query the database. But most of the times, APIs are the ways by which these layers interact with each other. Right? So that is basically how any product, any real product really works. Now let's go on to a little more technical concepts, a little more deeper concepts once we've understood these, right? So this is where, you're trying to get into system design territory. You're trying to get into slightly more detailed stuff. So we've understood these 3 layers. We've understood that every product works on this, and we've also understood APIs. But this is not enough to make a great product. Why? Because a great product will break at several places in the presentation layer, will break at several places in the application layer, several places in the database layer, and several places in APIs. So that is why there are a few common concepts that allow you to break, or that allow you to manage things. And the first one is called load balancing. Now imagine your product has got 1 million users, right? You put or let's say your product has 10,000 users. You put a server, which is you put one computer, and then you go ahead and it works fine. Now imagine it grows to 1 million users. But now that one server will not be able to handle the load of your users coming in. When I say handle the load, it will just not be able to process the requirements, because at the end what it is doing, it is getting the request from the front end. The front end is sending that, it is deciding whether it needs to get answers to that request via an API or via querying the database. But one computer can do it only one at a time, right? So one request comes, they will process it. Another one comes, they will process it. Imagine 1 million requests come together. So that is where, you would start doing it. But then after a period of time, because of having no breaks, the system will actually break down. It will crash. Which is why a big concept that companies use, a big concept that is really important for you to know, is distribution or load balancing. What happens in load balancing? Load balancer is very a simple concept. Basically, instead of one server handling everything, you have a cluster of servers, right? So instead of one server saying that I'll handle the 10 million, you have the one server 1 which handles 3 million, another server 2 handles 4 million, other server 3 handles 3 million. The more the load, the more balancing that it can happen, the easier it goes from there. Basically routing the request to different servers instead of having just one server to do it. Think about it as a restaurant, but since you are a very famous restaurant, you have multiple kitchens. So if 1000 orders comes in, your first kitchen is going to serve it. But the moment you have the 1001th order, 1001st order, that is going to be handled by the next kitchen, right? Otherwise, what will happen is these 1000 orders will make your kitchen very slow, and that is why. So essentially, you need several kitchens, and you need one coordinator to decide where all of this is going. So every product that we use at scale, right? WhatsApp, Instagram, Swiggy, Amazon, Flipkart, they all use load balancer. So whatever happens when you send a WhatsApp message, it first goes to the load balancer, and then once it goes to the load balancer, it decides which server it needs to go to, and that is how your decision goes. And then one of the servers serves it, and then that server decides whether they have to integrate it with a database, whether they have to query the database, whether they have to hit an API, and so on and so forth. Right? So that is why the first thing that you have to understand in servers is load balancing, and it's a very important concept from there. Now, the next part, or the next important thing that you need to understand from servers is stateless servers, right? Now, of course, one thing that has become very clear is that any product, right, the most important things in the product happen in this middle layer, which is the application layer. Front end is usually just interaction, it's just buttons, forms, etc. Doesn't break that much. Database layer is basically where, again, standard data is stored, it's most queries. The application layer is the main thing. So now let's try and understand the second problem, or the second way this gets solved. So you sign up on, let's say, Amazon or Flipkart. What happens is your request goes to the first server. Server 1 says that, okay, great, this guy is a registered user. Let's let him go ahead and add to cart, right? If you remember, a lot of products, they don't let you to add to cart before you are logged in, right? So they will go ahead and say, then the request goes to server 2, but the server 2 has no idea who you are, right? What happens here is, let's assume your first request from this load balancer went to server 1, and server 1 said that, great, this person is validated, allow him to add to cart, and sent it back to the front end. Now what happens is the front end then sends the next request, which is, now let's assume I've added to cart. Now because of the load balancer, it can actually go to server 2. What happens then? Server 2 actually does not know what has happened last time. So each server basically remembers its own users. So the system breaks the moment the load balancer routes your request to a different server. Which is why the important thing that we have to understand is the solution that is there, which is stateless servers. Basically, what are stateless servers? Stateless servers are basically ways by which no server remembers anything about the user. Every request is treated as a fresh request and as a first time request. So instead of all the remembering happening here, which is in the servers, the remembering happens in the database. So the database becomes the single source of truth. So when the server 2 gets the request to add to cart, it basically does not need to remember you, because it just asks the database querying saying that, who is this user? Please add to cart for him. The database says, okay, sure, I already have the validation that this user exists, and here is their cart. Go ahead and showcase it to the user. So server 2 has everything that it needs. So the second important concept that you need to understand is stateless servers, right? This is why, every platform actually wants you to sign up, because the moment you sign up on Amazon, Flipkart, Swiggy, etc., they basically know now, and they basically ensure that you can actually maintain a state based on which your preferences, order history, your likings, everything can get stored in the database. Now, sometimes there are a few things that don't need to get stored in database. These are temporary things that can get stored in your browser itself, called as cookies. So for example, let's assume that I don't want, someone is coming and browsing, right? Someone is coming and browsing airbnb.com, and that person is not logged in. Now, what do I want to do in this case? What do I want to do? I don't want the person to refresh the page and start from absolute zero, because the moment that happens, that person's experience breaks down, right? I want some minor informations to still be there. So what will I do? Instead of taking the entire route and saving their details on the database, which I cannot because the person is not logged in, so who do I save it against? I save those details in your browser's local memory called cache, and I store them as cookies. Basically information for you, which can be used for a small period of time, and then usually cookies have an expiry date. So it basically expires, let's say, after 24 hours, 36 hours, 48 hours, whatever, and then your browser is going to get reset. So basically it's a way by which we get some temporary memory from there, right? I'm sure a lot of times on a website it's there that, can I store your data, accept all cookies, and so on. When you don't accept cookies, what happens is every time you refresh, everything about your website gets reset. Sometimes, if for example, in a government website, there is a very long form, right? I don't want the form to get reset from scratch the moment something happens or the first refresh happens. So what I want to do is I want to store all this information in my browser's memory or in browser cookies for a while, right? For a small period of time, right? Because I want that, okay, whenever they've refreshed within those 10 minutes, 15 minutes, it still doesn't take away their entire details, right? So this is the other way in which websites basically decide what you are. Otherwise, the next basic concept is stateless servers, which is the server never decides who you are. The server never stores any information or never gets any information. It completely depends on the database. Sometimes it does not need to depend on the database. The front end does not need to depend on the database and the application layer. The front end can on their own decide where to store, or on their own figure out what's going on and use that. Right? So that is basically how data is getting stored and works out. Right? So that's concept number 2. We've understood how all products work. We've understood first concept, which was in servers, which was load balancers. We've understood second concept, which is stateless servers and stateful databases and browser cookies. Now the next thing which you have learned a lot and you've understood a lot is something called as CDN. What is CDN? CDN stands for Content Delivery Networks, right? Now the next problem, and once again, this problem happens on servers and databases only, not in the front end, is let's assume that your server is located in US, right? The server that is located in US, but your user is in Mumbai, right? Your user is sitting in Delhi, Mumbai, Bangalore, whatever. Every time they load a page, the request has to go through via the internet across the Pacific Ocean to the place in US and then come back. There's no problem in it. The main thing is that this is a slow process, right? Because the request going there, coming back is going to take a lot of time. So this is where CDNs or content delivery networks came in to solve this piece by placing copies of your content all across the world. So what happens, instead of your user in Mumbai hitting the server in Oregon, they're going to basically say that, hey, I'm going to hit a CDN here in Mumbai right itself, which is basically a replica of the content that is there in Oregon or Virginia or wherever. What this means is it is instant. This is how Netflix streams without buffering. So for example, let's assume that all the Netflix database or servers were stored in US. What will happen is every single time that data has to be flown and streamed, you will have to get that data all the way across the Pacific Ocean. Instead, what they happen is they create CDN nodes. They create a node in Mumbai, Bangalore, Singapore, etc. so that the movement of data happens very, very quickly. So whenever you press play on Netflix or Jio Hotstar or Prime Video, when you press, the video comes from a place that's maybe 50 kilometers away or 500 kilometers away, but not 15,000, 20,000, 30,000 kilometers away. This is how Instagram loads instantly, right? Even though their main servers are in the US, what happens is they have created CDN nodes in India, which is where this copy happens. Now the big CDN providers, the biggest one is CloudFront. This is called by AWS. Akamai gives you CDNs. Cloudflare gives you CDNs. You don't need to know how to set up a CDN, but you need to know what a CDN is. So when your engineering team basically comes and says, hey, okay, we'll use CloudFront to store all of this data, they basically mean that we are going to create copies of this data, put them across servers worldwide, and the users are going to get them fast. Right? As a PM, if your users are, of course, let's say one of the reasons why, let's say your users complain of latency, right? For us, for example, users in the US may complain of latency because all the data is stored in India. So this basically means that we need to take a subscription from Cloudflare, create a CDN node somewhere else in the world so that the load time is fine. Now, you don't have to actually worry about figuring out which location. Cloudflare does for you. Whenever there is, a location where a lot of requests are coming in, the Cloudflare will just create a replica of your data there, and then it would quickly go in, right? So that is basically the next concept that you need to know in terms of this. So just to repeat, we've understood the 3 layers. We've understood each of the layer. We've understood that technically the most complex is the application layer and the database layer. We understood the first concept within that, which was load balancing. Then we understood the problem with load balancing and why stateless servers and stateful databases are required. We also understand what cookies are and what cache is. And then we also understood what CDNs are, or how basically this data is ensured to move faster. Right? Now, basically we'll look at one more piece now next, which is caching. Right? We'll look at it a little deeply. Now, we'll look at something called as Redis for caching. Now, slightly complicated, this thing, but but still we need to understand this, right? Now your database is reliable, right? But sometimes there may be use cases where you would need high frequency items to be fetched from the database. For example, every time someone refreshes their LinkedIn feed, the server has to query the database, compute the feed based on the algorithm, which post should come first, second, third, fourth, and then render them on the app or website. What happens is millions of users use it and it becomes too slow for them if they keep refreshing their feed every time. Which is why the next solution that came in is called as Redis. What is Redis? Redis is essentially an in-memory data store. Think about it as your computer's RAM versus hard drive. Your RAM is small but really, really fast. Your hard drive is large but slow, right? Your hard drive may be 200 GB, 600 GB, 1 TB, etc. But copying, pasting on your RAM, on your hard drive is slower. Your RAM might be smaller, 1 GB, 512 MB, etc. But it will be much faster. The same thing is what Redis is. So Redis sits between your server and the database. Whenever a request comes in, the server first checks Redis, if it has this data already. If yes, it means that the cache gets hit and then the data comes back immediately. So basically what happens is the first part that you see, which is whenever a user requests something, whenever the presentation layer requests something, the application layer sees it, but they don't stop there. They actually go ahead and hit Redis first to figure out whether there is some data that is cached or not. The second is if Redis does not have data, then it means that the server has to query the database. So it gets the result, stores a local copy of that results in the Redis so that the next time whenever a new user is looking for the same data, they actually are looking at it from Redis and seeing it. Right? So if the first user will be a bit slower, but the second user or every user after that is going to get a faster outcome from this. Right? So every single time you keep, you keep storing this on Redis or you keep adding cache on Redis, you are going to be faster and faster for your next users. Right? So Swiggy's homepage, for example, right? If you, for example, just open that, right? When I open Swiggy, what happens is it does not query the database directly. What has happened is somewhere in Bangalore, someone else would have also opened swiggy.com in a similar location, right? If I open this, it will load pretty fast. It's already loaded, right? So somewhere, someone nearby or someone in this area would have already figured out food delivery, right? Otherwise, if you see all these images loading, all the top thing loading, all the options loading and so on is going to take some time. Right? So what has essentially happened is that Swiggy, the previous request is cached in Redis and based on that, it's fetched from there. So whenever as a PM you hear that, okay, we'll store this piece in cache, you know what it means. They basically store it in a Redis cache so that when one user requests something, the next user can benefit from the speed of it and the next user does not have to fetch the entire data again and wait for a longer time, right? So that is basically what Redis means, and Redis is just a way of storing it in cache. It's the name of the company that actually did it, right? So that is how you need to understand. Now, this is basically the full stack architecture of all the problems that we found in the core architecture. Your client is your website. This is your Airbnb.com, your LinkedIn.com, your Swiggy app, your Zomato app, everything. Then what happens is the first request gets hit to the Redis cache, right? So the middle is the entire application layer. It gets hit to Redis cache. If there is a hit, great. If not, it moves further. Then it would move to the load balancer, which is basically routing traffic to a right server. Then one of the servers figures out which server gets selected. Then because you want that server to respond fast, you will go ahead and hit a CDN, which is a local copy or a closer copy of the data. And then that CDN is going to hit the database, and then the database is going to go back with whatever information is there and reflect it on the client again, right? Take an example. Let's take a very common example. When you send a WhatsApp message, you type the message on your phone. So that's the client, the presentation layer. The message first hits the Redis cache. finding that, hey, is there any cache data that is relevant? Maybe your friend's profile picture or name or something like that. If that is there, it gets immediately loaded. If not, it gets loaded properly. It gets loaded, takes a bit of time to load. Then the request goes to a load balancer, which basically routes it. WhatsApp would have thousands and thousands of servers. So it would route it to one of those servers. The server then processes the message, encrypts it, validates it, figures out who the recipient is, if it's media, image, so on and so forth. And also it fetches all this from the CDN nodes instead of the main database, right? Of course, because if you fetch it from the further away database, it's going to take more time. Then that message gets stored in the database. So it gets stored in, persistently over the database forever. That becomes the source of truth, like we discussed. And then the entire chain reverses, which is the database then responds back to the CDN saying that, okay, this is the message to be sent. Then from there, the recipient's client gets rendered, and then your friend finally sees the message, right? So client, cache, load balancer, server, CDN, database. That's the full stack. Every single modern product on the internet built at scale uses this same stack. Right? Every single model uses this same stack. Right? Every single, whatever we see, whatever we do, every single time. Of course, broadly speaking, client, application layer, database is fine, but the application layer is a little more complicated than it seems on the way, which is basically you go ahead and figure out ways by which you solve certain problems like caching, like using CDNs, like using load balancers. Right. So that is about how you understand or how you this thing. The final piece of what I want to cover today is all about working with tech developers. Now, of course, one piece of it is to understand how these products work. But the final piece of what I want to cover today is how do you actually work with engineers, right? Now, the PM developer relationship is basically two pillars: empathy and clarity. The first is empathy, where I've picked up four pillars that you need to understand to work with engineers. First, invest in the relationship, schedule regular one-on-ones with your engineering lead. Don't discuss tickets, understand what's going on in their life, what are they dealing with, what's frustrating them, what was a mistake that PMs could improve, all of that, right? So try and build a lot of trust with your engineers. Second, learn the vocabulary, whatever we've studied today, of course, like compressing it in 1 hour, but you need to go through it again, maybe when you post it on YouTube, etc. So go through that, understand how the vocabulary works, terms, how they work, what they discuss, what they use. When they say DB migration, understand why are they migrating it, why are they DBing, and so on and so forth, right? Then of course, go ahead and bring your own research, right? Developers are very logical, so bring your own thoughts of why you are building this and come with data, talk to them, make them feel part of the decision. And then of course, involve developers early, right? So whenever you're building something, don't just finalize the solution and hand it over. Tell them that, okay, this is the reason why we picked it, this is the reason what we wanted to do, and so on and so forth, right? So the first pillar is empathy. The last pillar and the final thing that we are going to do is trying to have explicit communication. So I've created like a 5-step framework that you can use with developers to have like a pretty strong communication pillar. So you could have the nature of requirements, then what is that requirement going to be, the PRD basically, what are the processes that you're going to follow, Agile, Scrum, Kanban, whatever you're going to follow. How do you communicate proactively, right? Schedule daily stand-ups, attend stand-ups, speak to them, understand blockers, and then of course, clearly divide the responsibilities from them. To manage this, there is a small matrix that I created to work with your engineering manager, which is basically usually the reporting manager of your engineers. So if the question is around why we are building this, what are we building, then you as a PM need to own it and communicate it to the developers. If the question is around how we're going to build it, when is it going to go, and who is going to build it, is going to be decided by the engineering manager. But when you're going to build, you're going to be informed about it. But the discussions where they decide how they're going to build and who is going to build, you require to be part of those discussions. You cannot actually stand off there, and that is why we spent today's time to understand this, or we spend today's time to break down how a core product or how a famous product or any typical product moves or any typical product works. Perfect. Awesome. Great. Thank you so much for attending these. I mean, I really like the fact that most of you actually stayed right till the end, and that's actually really pleasing, and also spending your Wednesday evening with me. So, thank you so much for doing that. I will post this recording on YouTube and let you guys know on the channel itself, sorry, on the WhatsApp group itself. If you're not on the group yet, just write to me on WhatsApp and I'm going to add it to the group so that you can know whenever we are doing these sessions in the future. And yeah, thank you so much for joining, and I hope this was useful for you.